You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
So good morning. Hi, how are you?
Good morning.
Actually,
I'm
no,
good.
it's
How are you?
afternoon for you. Or
Yeah, it's
good
5
Abend.
p.m. So good morning to you.
So hi. So we actually tried to plan this a couple of weeks ago, and so what I normally like to do is have you introduce yourself, tell us your name, where you reside, and what company you work with, and then we'll get into a little bit more about the company you work with. So please, go ahead.
So my name is Ralf Wagner, and I'm working at Scoobe3D. We're based in Augsburg, and my position is in hardware development. So I developed the hardware of the 3D scanner. So yeah.
So yes, I read a little bit about your bio. Job position titling is a little different in Germany. They have you as a technician, but obviously you're electrical engineer. Is that correct?
Yeah, well, not electrical engineer, but engineering in general. So I studied engineering
Okay.
and specialized in optics with several. Yeah, I made several research at university regarding optics. So yeah.
Okay. So obviously, let's go ahead and get into the company. I thought the naming was a little unique. You have a phone call coming in?
Have to rangehen. Oder so. Okay.
Yeah, the life when you're busy,
Happens.
right?
Yeah, right.
So the name is Scooby3D, is that correct?
Yeah, it's Scoobe3D.
Oh, Scoobe3D, okay.
Yeah, right.
Now, obviously, I'm thinking Scooby-Doo for some reason. You've probably heard of that American cartoon.
Yeah, of course.
However, there must be more meaning to why you chose that name. Is there a German equivalent of Scoob? Or is it you just like the name?
Yeah, it's just a name we invented. So first we wanted to name a name that includes what we do, like 3D scanning and such things, but they were all taken. So we had to invent a word, which was Scoop. And then we added 3D so that we can implement that we do 3D things, like 3D scanning.
Oh, okay.
So basically, you can use it as a verb too. So you can like scoop an object to get a 3D model, or like scoop 3D it. So that's basically the name of our company.
Oh, okay. So as you just mentioned, you designed a unique type of scanner. There are obviously several types of scanners out there. So what I want to do is bring up the screen real quick. This is a PDF that you actually graciously put in your Kickstarter as identifying where you got your ideas from. This was a study done at MIT Lab. And you know what's funny is that I actually read about this particular this paper as well, and I said, wow, it'd be pretty cool if somebody actually applies it. And sure enough, actually you don't see it yet, so let me bring it up real quick. Here you go. There. And so
Yeah, right. Yeah.
So one of the things that I did in one of my previous podcast YouTube channel episodes was actually go through this, and I thought, what an interesting and novel concept. And obviously having somebody actually apply this process would be pretty cool. And here we are. When was this written? 2 years ago? It doesn't have a date on it. But so here we are in the end of 2018, and somebody actually has a product. And not only do you have a product, but you have a product that looks very similar to a smartphone. Is that correct?
Yeah, it's like the size of a smartphone, so you can put it in your pocket as well.
Well, one of the great things about video is that give us a chance to take a look at it. You got it with you?
Right now, so we have two kinds of prototypes. So we have one design prototype that's like a looks like prototype.
Okay.
Which is what you can see on a Kickstarter site, and a functional prototype, which is bigger, but it works completely. So software and hardware are implemented there and work.
Okay.
Unfortunately, our looks like prototype is at a fair here in Augsburg right now, so I can show it to you because it's busy showing other
Okay.
people.
Well, let's see. It'll be difficult since here I actually have a picture of all your prototypes, and so go
So
ahead,
in the
please.
front left, like the big square things, like the working prototype, which works as intended. And in the middle on the front, that's our looks like prototype. So this a product scanner that we will deliver next year. It will look like the scanner at the top middle, like in the front. And
Okay.
the ones at the back are like the first prototypes. So the very big one on the left is like the first that actually worked completely.
Which one?
Yeah. Like the very big one at the very back.
Okay, that was your first one that worked.
Yeah.
So what I see in that, well, we'll get to the lens system because I think that's very unique, and I think this is probably where you have filed your patent for. But it looks like you have an array of visible light LEDs. Am I correct there? And they seem to show up in all of your prototypes. And then obviously you have a camera system. And then I noticed you actually, down here in the bottom left, if it's to use a smaller unit before you have your display model there, you have two more sensors. So if I understand correctly, there is actually two versions that you have on Kickstarter, which I'll bring up here shortly. You have a Kickstarter that, go ahead and, actually I can go ahead and do that right. Where are we at? Let's bring up the Kickstarter. There we go. Okay, so changing that out. So here's your Kickstarter, and congratulations, you've exceeded your goal already. So.
Yeah, thanks.
And actually, I went through here, and I think you had exceeded it when I talked about it 2 weeks ago, or a week and a half ago. But a lot of your immediately went into where it's at the somewhere down here. You've already exceeded, or keep going. Yeah, all gone. So your €499 pledge is already gone. Dang, for July 2019, which means if you want to grab one of these, it won't be available to what, October and September and December we're looking at. Oh, okay, that's pledges. So it looks like August 2019, September 2019 is if you didn't get on the early bird versions, this thing will be available. So about a year from now.
Yeah, that's right.
Okay. Okay, so let's get back.
There's some special things for the first one who ordered it. So
Yeah, but they're all gone now.
Yeah.
Okay, so let's kind of get into this a little bit. And so you have an additional 3D camera. So you actually have two versions, if I understand correctly. You have a version that has the polarization unit, which I think is a standard visible light camera, and then you have an additional 3D camera, which is a time-of-flight camera. Is that what I understand correctly for the more expensive unit?
That's correct, yeah.
Okay.
The basic version just does not have a time-of-flight camera.
Okay.
So
let me see.
yeah.
Oops. Trying to bring up both of these on your, yeah. You've actually added more information about the scanning, which we'll get into in a little bit, but
so in comparison of the two scanners is more like on the bottom third, like of our campaign. We also added new 3D models. Just a little bit more down, I think.
okay.
Yeah.
Here we go. So we have the Scoobe3D, and then the Scoobe3D Basic. The Basic is the one that only includes the visible light with the polarization unit in front of it. And then the Scoobe3D includes that as well as the additional time-of-flight camera. Is that correct?
Yeah, right.
And
So
the time of... Go ahead, sorry.
So the time-of-flight camera, which is only in the Scoobe3D, this way you will get better accuracy. So the basic will deliver like 0.5 millimeters, and the Scoobe3D, like the kind of premium version, gives you an accuracy of 0.1 millimeters, and it also gives you absolute values, so you don't have to scale up anything afterwards. So you can also get 3D models that are scaled with a basic, but then you have to would have to use an Aruco board for reference.
Okay.
So the Scoobe3D does not require any scaling, so you get absolute values in millimeters.
Okay, so obviously it would be better to spend a little extra money and get the time of flight camera along with it.
Yeah, right.
For better accuracy and also proper scaling. All right, let's go through here and identify some of the facts, and then we'll get back into the hardware. So Scoobe3D Basic, polarization, photogrammetry, and then the Scoobe3D, keep saying it incorrect, right. Polarization, photogrammetry, and time of flight. Obviously, you're probably not going to let me know. What type of time of flight camera are you working with? Is it one of the newer ones that I've been reading about that's very compact, or has it been on the market for some time already?
So I can tell you like the exact model right now.
Okay.
So, but it's obviously a compact version because like a scanner is in the smartphone format, so it has to be a compact version of it.
Okay.
So just needed to get like a rough data points with absolute values from the model you're looking at.
Okay. Okay, and then obviously the accuracy on the Scoobe3D is 0.1 millimeter, which, as I know, as well as some of our audience who've been 3D scanning, that's pretty good, especially for a mobile unit, as you're probably also aware of. And also you can go to 2 meters by 2 meters by 2 meters, and for those of us in the American market that want to convert that, that's what, a little over 6 feet, right? By 6 feet by 6 feet, approximately. The American conversion.
I have to look it up, so I don't know what's the conversion. But it's 2 meters. Yeah. So.
Yeah. Actually, I could drop out of that screen and come back. Let's do this. Well, I think it's about 6.5, if I remember correctly. I'm not going to guess anymore. Let me do a conversion. All right. So let's go 2 meters to feet. 6.56 feet. So I was pretty close. Okay. So let's jump back to your Kickstarter. Okay, so that's fairly large. So if you wanted to scan a human being, you have that capacity with the Scoobe3D. Obviously, at 50 centimeters by 50 centimeters, that won't be the case. However, you'll be able to scan smaller items. And, you know, a lot of the questions I have here, I noticed that in your FAQ area on your Kickstarter, you've already answered. So we'll get to that in a second. All right, let's get back into hardware. What are you powering this thing with? What type of SoC? I'm assuming it's maybe a Snapdragon or a...
Yeah, it's a Snapdragon, like Snapdragon 820 right now with Android OS.
Okay, so you are using Android? What version of Android?
I don't know what we're going to use in our final product, but currently we're testing Android 8.1.
Okay, so it's a fairly recent version.
Yeah, right.
Will you have any other features of Android, or will this be basically streamlined to your application only?
So it's will only the device will only be there for 3D scanning and also for a quick preview of a 3D scan. Okay. So you won't use it like a smartphone, just like a 3D scanner.
Now, if I also understood correctly, you will have a smart card or a SD card slot for it. Is that correct, or did you?
Yeah, that's correct. So you can. So the scanning process is like you 3D scan an object, and then you're sending your data to our server. Then we calculate your model, and then the model will be sent back to your Scoobe3D. And if you don't have any internet connection, you can store the data on your Scoobe3D. You can also store the 3D models on your Scoobe3D. So that's why you need why we implement an SD card.
Okay. But it also has Wi-Fi as well, correct?
Yeah, that's correct. So you can send your data.
Okay.
Wireless.
So it's very versatile from that perspective. How much battery time do you think you'll be able to achieve on it?
I can't tell you how much battery life we can. We didn't test it yet, so.
Oh, okay. So it hasn't actually been
You know
tested
it.
yet.
Yeah, so that's why we're on Kickstarter, so we can build like the final product, and then we
Okay.
can see how much space there's for battery, and so how much battery life you will get respectively.
What's the actual
But
battery? I'm sorry, the display. What type of display are you using?
the display and battery we only have specified like the 3D scanning parts, so like
Okay.
on how to get a 3D model. Like the other parts, I will be specified later on. So I think it will be HD display at least.
Okay. So probably a 1080p screen or something. Okay.
That will probably be the case.
So what is the progress on the actual software end of it? One of the things that I've noticed with a lot of the scanning units out there, the software kind of makes or breaks the product. What kind of tools will you have? You'll have a capture capability. Will you have any editing in the phone, or are you going to leave that to an external package?
So like our software does like everything. So you will just scan your object. So all the pictures you need will be taken automatically. Just guide it around like you're taking a panorama picture. Then all the data will be sent to a server, and then calculation happens, and you will get like a 3D model.
Okay, I've got a little demo, or actually, I don't know if it'll actually show up completely. But if you notice, I've got a little video.
In this
running
video,
here
you will learn
the
how
actual
Scoobe3D uses
process.
polarization for
This is
3D
the
scanning.
unique part
I
of
can hear the video. I can't hear you.
At first, we are tilting a polarized filter.
There we go. Now you can hear me,
that's
correct?
better.
Okay.
Right.
So you're showing the purpose, and if some people want to know more about this, they can read the PDF. But the polarization is one of the more extremely important things because it now allows you to look at objects that have specular reflection and things of that nature, which is, as we know, if you've been using any other type of scanners, since they work off reflected light, black objects, reflective objects with a lot of mirrors, obviously, can create some problems. But that isn't the case with your product. Is that correct?
Yeah, right. So you don't have to like coat any materials that are shiny, like metals or something like that. You just can just 3D scan it.
Okay.
Again,
So, go ahead. Sorry.
yeah. So with structured light, for example, you can't scan any shiny surface like metals or something. Because you get all errors, and you won't get any scan data at all if you don't use any coating spray. And as you saw in the video, like polarization just remove all the reflections, and then you can scan it like a normal object.
Yeah, and I noticed that in some of the other demos that I saw as well. Okay, so right now we're going to actually take a look at, because I know that you got to leave here in about 9 minutes, so I'm trying to keep that in mind. So I'm loading a model now. I'm assuming this is one of your first models, and
Yeah, that's right.
and you actually show or at least the demoing of you scanning this particular model in your your intro video that you have on Kickstarter. So I'm assuming that this was probably not done at the same time. So why don't we kind of run through it? One of the things that kind of jumped out at me is that even though we've got some good surfaces, there still seems to be some noise that is, similar in some structure. Now, how was this done? Was this done just with the photogrammetry functionality, or was this done with the photogrammetry as well as time of flight?
So this is like all technologies combined. So this is especially hard to scan because like the roof of the car, it's black and shiny. So most scanners don't get any data on that point.
Okay. So as I saw in the
It's
video,
more like a development object, because you can tune out the algorithm is very good with this one. So we don't scan like the bottom part of the thing at all. We just scan the top thing, just for development. So that's.
So the important thing behind this one is the fact is that you had a lot of shining surfaces, and as those who've done a lot of scanning, and not just structural, I mean, a lot of laser scanners don't do a very good job with reflected, like the Next Engine and things like that. So clearly, to be able to get something like this, and this is a raw scan, no editing, no cleanup,
Yeah,
nothing.
right. That's raw scanning.
So that's actually pretty impressive. In fact, you'd be hard pressed to get something like that out of a structured scanning device. All right, let's take a look at this little figure here, which looks a little better, but if I remember correctly, one of your videos show you actually scanning this. It is not reflective, correct?
Yeah, right. So it's made of wood.
So as you can see, the detail is pretty impressive. Now, how large was this object?
I think like 20 centimeters or so. Around
Do you actually have it there in the room?
Yeah, I can look for it right now.
Okay.
So, give me a moment.
Okay. So while he looks at it, I think there was some video on it. So he actually scanned this. And again, this is basically, if I remember correctly, he just circles the object, very similar to photogrammetry. And then I'm assuming his stitching application takes care of putting it together like this.
Okay, so
Okay.
the statue is also at the fair. I just saw.
Oh, okay. So 20 centimeters. So we're looking at
So sorry for that.
probably 4 or 5 inches. If I is it about that? So it's not a very large object, right? It's about, well, you can't see
It's
my
like
hands.
this, like a head or so.
Okay, so about maybe a foot then. Now I noticed that these do not have any texture, and it appears that you have a chair, and then you have this one here, which I think was one of your first, dog in clay, that also shows color. So one of my questions is, do you do both UV capture as well as vertex capture, or is it only vertex capturing?
So the capturing is vertex based on like every point has its own RGB values.
Okay.
So yeah, that's from like photogrammetry. So that's like
All right.
how we
So
capture the color information of the object.
okay. So obviously your texture your detail is going to be dependent upon the number of vertices you have. Are you also planning to create a UV export as well?
We didn't plan it yet, so
Okay.
I can keep
You'll
it in
have to
mind.
bring it into another application in order to do so. Well, and as I wrote in one of my questions, some of the UV methods that are used by other companies, you're probably familiar with Scoobe3D, who does a really good job of using the iPhone camera with the structure sensor in order to capture detailed RGB information. But they use what they call strip UVs, where they just have a whole bunch of little clips. And I find that for using them in 3D visualization engines, you normally have to go back through, and I've had to remap the UVs. So they're great for getting a great presentation that you can put in Sketchfab, but they're not really optimized. So if you do plan to do UV mapping, kind of keep that in mind. That really helps to have a nice compact UV map. Okay, so let's look at something that takes advantage of the photogrammetry functionality. And
where we just place it on the floor and go guide our scanner all the way around it. Then we turn it around, we get the bottom part, and then we scan it again. And then our software fused all together to like this 3D model you can see here.
Okay, so it basically was all done within your device, and then this is what you got. Now this is Vertis RGB information here?
Yeah, it should be, yeah.
Okay.
Of course.
So let's see, I'm not going to waste my time here, but essentially you can look at the number of vertices. This is out on Sketchfab. When we get done with this, there'll be links that show all the things that we're talking about, and you'll be able to go out and look at these yourself. Okay, so last kind of things. Obviously, your market is going to be around the Arctex scanners and the Einscan scanners.
Yeah, right.
And and at this being competitively priced at what, 599 euros for which version?
So the basic version is like 599.
Okay, and that's just photogrammetry.
Yeah, photogrammetry and polarization. So you get like 0.5 millimeters for
Okay.
smaller objects. And
And then-
like bigger version, which also includes time of flight, will be priced at, let me see, like 12.99, I think. Or right now.
So I see a pledge of 975.
Yeah, 975. So that's
Okay.
the 20% off retail.
Okay, and what's the euro
Kickstarter.
version right now if you're in the United States? Oh, actually, it says right here. So a little over $1,000, almost 1,200. So that's not too bad. Obviously, you're probably familiar with the price of an Artec scanner. It's $10,000 to $20,000, depending on the model. And then the Einscan scanners, I think they have a model again, probably at around $2,000-$3,000 if I remember correctly. So this is competitively priced.
Scanners are pretty expensive, so.
Yeah, and now obviously I just mentioned the word structure sensor, which is about $350. But the fact is that you use polarization as well as time of flight in the $1,000 price range gives you 0.1 millimeter accuracy up to 2 meters by 2 meters by 2 meters, 2 meters cubed, and obviously very high detailed RGB textures. And so if you go ahead and sign up now, you'll be able to get one of these by August of 2019. Is that correct?
That's
or
correct,
actually
yeah.
July 2019 would be the earliest you can.
Yeah, right. That's July 2019. So 1 month.
Okay, so there's still 136 units left. Okay. And again, all the stitching is done within the camera unit, and then I'm assuming that object can be either put to SD card or sent over Wi-Fi to be brought into another conversion. Go out to the fact pages if you want to know more about, if I understood correctly, you do mention that this could be used for creating models, and if you go back out to Sketchfab, you have a couple of models that if you were going to be using this for creating molds or for tool set or for creating components and parts. I'm not going to bring them up here. You can look at them yourselves, but essentially there's really good detail. I noticed there's some circular deviations, especially in this mechanical spare part.
Mm-hmm.
But again,
so it's actual metal too, so it's shiny.
Okay, so the shiny
surface.
object is okay.
Yeah. So we have one shiny surface to show.
Okay, and it looks really nice. Again, even though there's a little distortion in this portion that can obviously be cleaned up fairly quickly. But the point I wanted to make is this is not CAD ready, and you will not have a CAD conversion process. You'll have to bring that into another package in order to convert it to, let's say, SolidWorks, Fusion 360, Inventor, or something like that. Is that correct?
Yes, so you will get an STL file or object file, so you can always derive the STL file to step, and then import it to SolidWorks, and you can rework it then if you want to, or like use it as a negative form to build something on it.
Okay,
so
which I've done before,
of course.
Now,
But
did you
need
say you?
different software for this?
Okay, so do you convert to step file, or you'll need another application to do so?
So we deliver. So you will get the 3D model in STL.
Okay.
And then you can use another software to, like, not our software, but third-party software, like, I don't know, I think SolidWorks can do it, right?
Right.
Yes, then you can derive your STL file which you will get from your Scoobe3D to a step file, and then you can use it for any kind of post-processing you want to do.
Okay.
Or like for reworking, or like, I don't know, building upon it, whatever you want to do.
All right, so to go to CAD or CAM, you'll still need a software to do this properly, and some of the conversion software can be quite expensive, but the fact is that we have such a clean model to begin with, obviously will expedite that process. And even with some of the laser scanners that I'm familiar with that are much more expensive, I still have to do a lot of work. So this is obviously very good. It's mobile, which means you could take it anywhere you want, put it in your pocket, call somebody on it. No, just kidding. You can't call anybody. But who knows? Maybe when it
You can
finally
scan
releases.
anybody.
So I'm looking forward to it. You might want to go ahead and put some human beings out there, scan a face or something in the future. I'd like to see how that would turn out.
We will also scan a room maybe in the future, because we can, like, the object size is not really limited. It's just, the bigger the object, the longer the calculation takes.
You said you'll
So
be able to do room size scanning?
Yeah, right. Of course.
Oh, wow. Well,
So just,
yeah,
like also with a Scoobe3D Basic, you can also scan bigger objects than 50 centimeters, but then you will get of course, a lower accuracy of like maybe 1 millimeter, 2 millimeters, depends on the size. So you can also always scan bigger objects, but then the accuracy will decrease.
Okay.
Course.
However, that's the case with most other scanners. As you increase the size, your resolution decreases.
Because we're working with photogrammetry, you can always stitch together all the pictures you have.
Okay.
So it doesn't really matter which size you have.
And again, you're doing this all in camera.
Yeah, right. So, yeah.
And, for some of you who have actually used your smartphone for photogrammetry, normally you push them up in the cloud to take care of that functionality. You're not actually stitching them together on your phone. So your product will do all this, so that doesn't mean other than sending it to your desktop through Wi-Fi, that's not necessary. You'll be able to have
the calculation does not take place on your device.
Oh, it doesn't? Okay.
No, so you scan the data, like you scan your object and you get your data, which will be saved to your Scoobe3D. And then your data will be sent to our server, then the calculation takes place and you get back your 3D model.
Okay, so it is still cloud-based. So if I wanted, let's say I didn't have a Wi-Fi connection or a radio connection, will I be able to do a bunch of scans and then upload them later, or am I?
Yeah, you can also start a scan and pause it and resume your scan later. It will all be saved on your SD card, so you don't have to worry that you don't have any connection or.
Okay, and I can do multiple scans. I can finish once. Okay. All right. So if I don't have a connection, I won't lose anything, and then I can upload it when I have a faster connection. Is that what I understood?
Yeah, that's right. You can go out to scan some flowers or something like that, and then you can back home, connect to your local Wi-Fi, and then you can send it and get your 3D model.
Okay. Wow. Answering all my questions. Well, if you get a chance, put up a human being, put up a room in Sketchfab so other people can look at it. I want to remind people that you've got 6 days to go, correct?
Yeah, that's right. I think it's 6 days. So also when we reach like 100K, we will meet our stretch goal, and then we will ship our software for all those first buyers on Kickstarter.
Oh,
so you can have a standalone device.
Okay, so that's if you meet it. Is that an additional cost, or will be included free if you reach your stretch goal? Now, let's say I don't.
So stretch goal, when we reach 100K, all of the backers on Kickstarter will receive our software for free.
Okay, and what would the cost be if you don't reach the stretch goal? I'm assuming you will, but.
I don't know. We didn't talk about that yet, so I can tell you. We don't probably will release it afterwards, like after Kickstarter.
All right, so let's say I don't meet your 6 days. Will this be for pre-order on a website?
Excuse me, I didn't understand you.
Let's say I don't buy it through your Kickstarter. Will it be available on your website for purchase?
I think you'll be able to buy it after Kickstarter too.
Okay, and what will the cost be?
So let me just look up real quick. So Kickstarter special price is like 30% off. Okay, so without Kickstarter special price, it's like For the basic version, it's I think $6.99, and for the Scoobe3D like premium version, it's €12.99.
Okay. All right. And obviously, those who backed you on the Kickstarter are going to get it earlier. If you don't make it through the Kickstarter, when would they expect arrival of their product?
Like if you don't buy it through Kickstarter, when the product will be shipped, or what's your question?
When will it be available if I don't buy it through the Kickstarter?
Actually, I can't tell you right now because I don't know.
Okay.
I don't know when the other devices will be shipped. So I have
Okay.
to ask our marketing for that because I'm a developer. I don't know all of our marketing strategies, like not out of mind. So
All
I
right.
have to
So
ask them. I think we will release it on our website when and how to get it, like after Kickstarter, of course. So it's not
earliest they
Kickstarter exclusive. Can always
so
get
the
our scanner.
so if you back it through the Kickstarter, earliest you'll be able to get it is July of 2019. Was that correct?
Yeah, that's like the first batch, probably.
Okay.
So it takes a bit of time to set up all the, like to get a manufacturer and all that. So we set a larger time frame so we don't have to delay it.
Okay.
So we will also start all the setting up right after Kickstarter so we can start production. And
Where will
final
production
testing.
take place?
That's not determined
Okay.
yet. So
Okay. Well, obviously, I've taken more than my 30 minutes with you.
yeah.
Okay, Ralph. So I'll let you go, and I really appreciate it. You've answered quite a few of my questions, and hopefully the audience